Hi, Joel. So here's to answer your question. So you've got this function, f of x equals x minus 3 divided by x squared minus 4x plus 3. So what if you plot this function, it's going to look like this. So obviously there's a discontinuity here at x equals 1. So the function does not exist at x equals 1. So you might limit the domain to every real number except x equals 1. And coming over here to x equals 3, which is where they're asking for the limit of the function. So what they're asking for is what is the limit as x approaches 3 of the same function. So if you look at the graph, you'd say, well, here's x equals 3. The value of the function is about a half. So you'd say the limit is a half, but you'd also think that this thing is continuous. But the reality is that the function does not exist at x equals 3. And we'll see more about this in the next section. But if I take this function and I factor the denominator, I'll have x minus 3 times x minus 1. So as far as the domain is concerned, you have this vertical asymptote at x equals negative 1. X equals 1. And you also have this, what we would call a hole, where you have an indeterminate result at x equals 3. So if I looked at the domain, you could say all real numbers except x equals 1 and x equals 3. You could say negative infinity, x is greater than negative infinity and less than 1. It's between 1 and 3, and it's between 3, not including 3, greater than 3, to a positive infinity. Or like you did, you could show it a curved parenthesis, negative infinity, comma 1, curved parenthesis, 1 comma 3, and 3 comma positive infinity. So these curved brackets are showing that I'm not including the endpoints. So again, the domain doesn't include x equals 1 because that's where you have the vertical asymptote. And it doesn't include x equals 3 because you have an indeterminate result. So hopefully so let me read the problem, make sure I answered all the questions. What is the domain of the function? So I've explained that. Can you detect a possible error in determining the domain of the function solely by analyzing the graph generated by the graphing utility? Well, the explanation would be that there's only one point missing from the domain, but the limit does exist, so you don't really see that on the graph because it's going to plot every point except that point, and points don't have dimensions, so you wouldn't see that discontinuity there. So it says, write a short paragraph about the importance of examining a function analytically as well as graphically. So there we're just saying if you graph something, sometimes you don't capture all of the discontinuities. You can capture limits, but you can't capture places where the function does not exist.